Welcome to aminacademy.com. In chemistry, let us discuss about ionic bonding. And ionic bonding is the complete transfer of valence electrons between atoms. It is the type of chemical bond that generates two oppositively charged ions. In ionic bonds, the metal loses electrons to become a positively charged cation, whereas the non-metal accepts those electrons to become a negatively charged ion. Look at the figure. Here sodium atom. Here one sodium atom have one excess electron in outermost orbit. It transfer complete to the chlorine atom. Chlorine atom already have 7 valence electron. It accept 1 electron. Here after losing 1 valence electron, the sodium becomes positively charged ion, and by accepting 1 electron, the chlorine atom becomes negatively charged ion. And then a strong bond between sodium ion and chlorine ion happens, that is called ionic bond. Then further, because of the opposite charges attract, cation and anion should attract one another. This is exactly what happens when an ionic bond is formed in sodium chloride formation. In the case next, let us discuss about salt, an ionic compound that forms when a metal atoms or a positive radical replaces the hydrogen or acid. Here the force of attraction between the positive charge on the sodium cation and negative charge on the chloride anion creates an ionic bond in sodium chloride. Recall that sodium chloride is the scientific name of the table salt. All these salts are ionic compounds that are electrically neutral. They are made up of cation and anions that are held together by ionic bonds in a simple whole number ratio. For example, sodium and sodium chloride consist of sodium cations and chloride anions bonded in 1:1 ratio. However, the attraction between the ions in a salt do not stop with a single cation and single anions. These forces are so far reaching that one cation attracts several different anions. At the same time, each anion attracts several different cations. In this way, many ions are pulled together into a tightly packed structure. This tight packing of the ions causes any salt, such as sodium chloride for example, to have a distinctive crystal structure. The smallest crystal of table salt that you could see would still have more than billion sodium and chloride anions. Now, transfer of electrons involves energy changes. Recall that ionization energy is the energy that it takes to remove the outermost electrons from an atom. In other words, moving negatively charged electrons away from an atom that will becomes a positively charged ion requires an input of energy before it will take place. Look at this example. Look at this equation. For example, here sodium atom plus energy gives sodium positive ion plus electron. Here by electron affinity, look at this, chlorine atom plus negative electron gives fluorine negative ion plus energy. Salt formation involves sometimes endothermic steps as well. Salt formation involves exothermic steps also. Means it absorbs energy, exothermic it releases energy. Next we'll discuss about lattice energy. The energy associated with constructing a crystal lattice relative to the energy of all constituent atoms separated by infinite distances. Here, the energy released when ionic bonds are formed is called lattice energy. This energy is released when the crystal structure of a salt is formed as the separated ions bond. In the case of sodium chloride, the lattice energy is greater than the energy needed for the first formation steps. Here, the value of the lattice energy is different if other cations and anions forms for salt. For example, sodium plus ions can form salt with anions of any of the halogens. The lattice energy values for each of the salts are about the same. However, when magnesium cations and with Mg2 plus form salts, these values are much higher than the value of salt of sodium. For further detail, we will discuss in later videos. If you have done, please subscribe our YouTube channel.